In 1940, the British War Office faced severe equipment deficits. The evacuation at Dunkirk caused massive hardware losses. Infantry rifles remained critically scarce for home defence. Planners needed a weapon for irregular resistance units. Requirements emphasised speed and low production cost. Major Shepard and Mr. Turpin developed a simplified firearm. The machine carbine used a blowback operating system. The prototype used a seamless steel tube receiver. Designers designated it the Sten machine carbine. Early blueprints specified mild steel components. Stamped parts replaced traditional machined forgings. The Mark I variant included a conical flash hider. Early production trials took place at Enfield. Engineers noted the trigger mechanism's simplicity. The bolt assembly was a heavy steel cylinder. A fixed firing pin was machined into the bolt face. This removed the need for complex internal springs. Tolerances were deliberately broad for rapid assembly. Local bicycle shops received contracts for small parts. The Mark II removed wooden furniture for efficiency. A simple T-shaped steel buttstock replaced the earlier pattern. The barrel measured approximately 7.75 inches overall. Technicians used a simple latch to secure the barrel nut. This enabled rapid disassembly and concealed transport. It used 9mm parabellum from captured stocks. Magazines held 32 rounds in double-column form. Yet the magazine housing rotated 90 degrees for storage. Magazine feed lips often needed manual adjustment. Stamping frequently left burrs on magazine casings. Armory workers smoothed these edges with hand files. The finish was a low-cost phosphate coating. Some batches received simple black enamel paint. War Office memos recorded inconsistent paint thickness. Excessive heat made the enamel smoke during firing. Workers applied oil to prevent surface oxidation. The bolt moved inside the receiver via a cocking handle. A safety notch held the bolt to the rear. Accidental discharges occurred when dropped on the butt. Tests identified sear engagement failures. Trigger spring tension varied between lots. Inspectors used a weighted gauge for trigger pull. Pull weights under 4 pounds were rejected. Rework caused significant delays in 1941. The Ministry of Supply demanded higher weekly output. Subcontractors struggled to hold specified internal diameters. Scrap rates at smaller workshops reached 15%. The tubular receiver needed a precise longitudinal slot. Milling machines cut the cocking handle slot. Rough slot edges made the bolt bind. Debris from workshop floors often entered the receiver. Grease mixed with swarf formed a grinding paste. This caused jams during sustained fire cycles. Soldiers reported frequent failures to extract casings. The extractor claw was hardened spring steel. The brittle claws snapped under high-velocity round pressure. Heat treatment ovens required precise temperature calibration. Records show several batches were quenched too early. Those brittle parts reached the London assembly line. Field reports from 1942 noted these breakages. Replacement extractors shipped in small tin containers. Each container held 50 units and a flat screwdriver. Barrels used 2-groove or 6-groove rifling. Tests showed 2-groove barrels were accurate at short range. Her 2-groove barrels took significantly less machining time. The smooth exterior helped disguise the weapon. Resistance groups received weapons by parachute drop. Standard containers held 15 Mark II carbines and ammunition. Packing lists included a small assembly instruction manual. The manual relied on simple diagrams, not technical text. Fighters stored components in civilian toolboxes. The disassembled receiver resembled plumbing pipe. The barrel resembled standard industrial conduit. Though this profile eased movement through checkpoints. German patrols often overlooked components during searches. The crude look functioned as camouflage. Spring materials came from furniture manufacturers. Steel shortages forced lower-grade alloy use. Compressed springs often lost tension after 3 weeks. Full magazines fatigued follower springs quickly. Operators were advised to load only 28 rounds. This reduced pressure on the feed mechanism. Though the magazine housing was a frequent failure point, loose rivets let the housing wobble in operation. A wobbling magazine causes misfeeds and chambering errors. Welders used spot welding to secure the housing. Poor penetration caused structural failures in the field. Inspection stamps were applied under the receiver. A broad arrow mark signaled government ownership. Some covert weapons lacked identifying marks. The Mark III used a fully welded steel body. Yet its barrel was permanently fixed to the receiver tube. This reduced the total parts count for assembly. The Mark III was not easily repaired. Damaged barrels required disposal of the whole weapon. Mark III production concentrated at Linesbros Limited. The factory used large stamping presses for the body. A top rib provided a basic sighting plane. Front sights were a simple steel blade. Rear sights were a fixed peep for 100 yards. Effective range was often under 50 yards. At high cyclic rate reduced controllability. Muzzle climb rose quickly and full automatic. 3-round bursts were the recommended method. A change lever allowed semi-automatic fire. The lever sat near the trigger guard for thumb access. Friction often made the lever hard to move. Oil seepage into the trigger group attracted dust and sand. In North Africa it needed constant internal cleaning. No forward handguard led to burned hands. Users held it by the magazine housing or barrel nut. Gripping the magazine could tilt it and cause jams. Special instructions prohibited holding the magazine while firing. The Mark V added a wooden pistol grip and stock. It was intended for airborne infantry. It included a bayonet lug for the No. 7 bayonet. The front sight was protected by metal wings. Mark V manufacturing cost was significantly higher. Internal components remained the same as Mark II. Logistics officers complained about added wood weight. They said it was light enough for female operatives. The SOE distributed thousands across European networks. Local forges produced clandestine copies in occupied territories. Polish workshops built the Błyskawica carbine. Those copies used screws instead of welds. The Polish design improved ergonomics. British planners reviewed these changes for later models. Pendine Sands testing evaluated reliability. Trials included immersion in mud and salt water. It outperformed many more expensive weapons in tests. The open bolt design let water drain quickly. Sand cleared easily by shaking the receiver. Small stones were the debris most likely to stop it. The cocking handle could lock forward. This served as a secondary transport safety. The handle could snag on clothing or webbing. Later handles used a larger circular knob. These were easier with thick gloves. The return spring sat inside a steel sleeve. The sleeve prevented spring buckling under load. It also guided the rear of the bolt. The sleeve manufacture required precise sheet metal rolling. Unflush seams caused internal drag. Workers used a mandrel to check circularity. Sleeves failing the gauge were scrapped. Barrel nut threads used a standard Whitworth pattern. Cross-threading was common among untrained users. Damaged threads prevented securing the barrel. Posters stressed careful thread alignment. The Sten lacked a traditional safety catch. Its safety was a notch in the tube. This simplicity was an advantage and a danger. And it could fire if jarred with a chambered round. Bureaucratic reports estimated thousands of accidental injuries. The War Office issued safety warnings in 1943. Training stressed carrying with the bolt forward. A loaded magazine was inserted only before combat. Its sound signature was distinct and metallic. A specialized version was made for silent operations. This was designated the Mark I YS. The suppressor used internal baffles and spacers. The barrel was ported to bleed propellant gases. This reduced muzzle velocity below the speed of sound. The Mark I IS needed frequent suppressor cleaning. Carbon buildup filled voids between baffles. After 300 rounds, suppression became ineffective. Suppressor heat could melt a rubber barrel wrap. Canvas sleeves protected the hands. It remained the primary British Army SMG until 1953. Over 4 million were produced across all marks. Unit cost was about £2 sterling. This made it the most cost-effective firearm of the conflict. Simplicity enabled decentralized manufacture. Large factories focused on bolts and barrels. Small shops made stocks, triggers, and housings. This network resisted disruption from bombing raids. Ledgers tracked parts flow to assembly hubs. Part count discrepancies delayed final delivery. High tensile wire shortages hit spring production in 1944. Substitutes came from piano manufacturing. Those springs had slightly different compression rates. Armourers colour-coded them for identification. So blue marked standard bolts, red marked experimental. It was often criticised for its rough appearance. Soldiers called it the Woolworth Special and Plumber's Nightmare. Despite appearance, it delivered high volumes of fire. The 9mm round suited urban and forest combat. Magazine capacity exceeded most contemporary rifles. Hand-loading magazines was slow and difficult. A lever-action tool was issued to speed loading. That tool was often lost by infantrymen. Without it, her rounds were pushed using a table edge. The magazine follower was cast aluminum. Later versions used stamped steel to save aluminum for aircraft. Steel followers tilted and bound more readily. Graphite powder lubricated magazine interiors. Liquid oil drew too much dirt into magazines. Manuals forbade heavy grease on the bolt. Grease slowed bolt travel in cold weather. This caused light strikes and failures to fire. Dry firing could damage the fixed firing pin. Worn pins required replacing the entire bolt. Some lots numbered bolts to match receivers. Most parts were interchangeable between units. This modularity eased field repair and salvage. Broken guns could be cannibalized for spares. Discarded receiver tubes were simply scrap. The trigger sear's simplicity was a manufacturing triumph. It was one hardened steel piece with two notches. The sear pin was a steel rod held by a cotter pin. Trigger guards were bent metal strips. The guards often bent during rough handling. A bent guard could block trigger movement. Soldiers straightened guards with pliers in the field. Weight balance sat near the center. This supported hip fire during assaults. No front grip encouraged that style. Sights were rarely used at close quarters. Instinctive aiming was the main method. Low 9mm recoil supported this. Blowback action absorbed much kinetic energy. The heavy bolt countered the explosion's impulse. Yet the ejection port sat on the right side. Hot brass ejected with significant force. Shooters avoided burning their forearms. Left-handed users found it hard to operate safely. The cocking handle moved back toward their face. No official left-handed version was produced. It remained a weapon of necessity and harsh logic. It served as a short-range suppression tool. Its presence in occupied territory had a psychological effect. The threat of a hidden weapon remained constant for occupiers. The resistance fighters valued concealability above all else. His legacy was framed as industrial efficiency. It showed lethal weapons could be made from screwy. Post-war analysis confirmed reliability across varied climates. It influenced the later Sterling SMG. The Sterling addressed ergonomics and safety. It lacked the Sten's extreme ease of manufacture. It stayed with secondary units for decades. Surplus stock sold to many nations in the 1950s. Its silhouette remains recognizable today. It remains tied to clandestine war in Europe. It was shaped by bureaucratic desperation. The Ministry of Supply finalized it in record time. Design to production took less than 1 year. The Mark I was approved in mid-1941. The Mark II weighed about 6.6 pounds empty. Length with stock attached was 30 inches. The barrel could be removed in under 10 seconds. This feature was unique among era submachine guns. Its simplicity was its main tactical advantage. And it took little training for a recruit to master. The manual of arms was taught in 30 minutes. Cleaning disassembly, it was straightforward and logical. Users unscrewed the back cap for spring and bolt. The receiver was wiped out with a rag. The lack of fine threads made this fast. It was born of total war conditions. It was built for a specific urgent requirement. It succeeded in giving mass firepower. Every part was designed for utility and speed. It remains a case study in wartime engineering. Our records show millions of man-hours saved. Steel consumption was minimized through design choices. It helped Britain rearm quickly. It also armed underground movements across a continent. Its crude finish became its signature. A Sten with a civilian was a potent threat. It served its purpose through the conflict's end. It was a tool for a specific brutal warfare type. Its industrial history is well documented. Factory logs describe quality control struggles. And inspectors in 1942 reported many bad welds. Correctives included new welder training. Jigs helped standardize the magazine housing. Its evolution followed changing wartime needs. The design moved from Mark I complexity to Mark III simplification. It was described as minimalist lethal design. It was called a vital Allied asset. It was the primary weapon of British paratroopers. Its compact size suited jump operations. Troops strapped it to their legs during drops. A Mark II breakdown capability was critical. Pieces fit inside a standard jump smock. Fewer protrusions reduced parachute line snags. Tank crews also received it for self-defense. Short length allowed turret storage. Crews preferred it over the Enfield rifle. It gave immediate firepower when exiting vehicles. Its 9mm caliber was standardized across forces. This enabled sharing ammunition with captured stocks. The MP40 used the same parabellum rounds. That logistics officers prioritized that caliber for European operations. Its magazine was a direct copy of the MP40s. This allowed use of captured magazines. Its magazine housing was slightly tighter. Captured magazines often needed filing to fit. Firing pin condition required constant inspection. Worn pins caused primer ignition failures. Armourers checked protrusion with a depth gauge. If protrusion fell under a limit, the bolt was replaced. The recoil spring used high carbon steel. The spring length was about 10 inches uncompressed. Constant use gave the spring a permanent set. A shortened spring increased rate of fire. This increased wear on receiver and bolt. Service life was intended as 5,000 rounds. Many units exceeded that in combat. Receiver tubes eventually warped from heat. Warping made bolt travel uneven. This led to runaway firing where it would not stop. Stopping a runaway gun required pulling the magazine. Training included that emergency drill for recruits. It was built from mechanical compromises. Each compromise was a calculated War Office risk. The risk was accepted given the strategic situation. It provided the fire volume needed for victory. Its history was linked to Britain's survival. It was described as a pipe gun that changed history. Production became a major logistical undertaking. Over 300 companies produced parts. Coordinating suppliers became a major bureaucratic task. The design was refined to improve production flow. The Mark II was the most produced. The Mark III was the cheapest and fastest. The Mark V was the most refined and user-friendly. Its impact on small arms design was significant. It showed expensive machining was not always necessary. It helped normalize stamped metal firearms. It was described as British ingenuity under crisis. It was described as a tool of liberation. Its story was described as industrial and military success. It was described as defying odds and changing history. So it was described as defining a generation and reshaping war. It was described as proving less could achieve more. It was described as securing the future and enduring. It was described as made by the people and widely used. It was described as feared by the enemy and valued by the liberated. It was described as central to resistance and victory. It was described as the Sten itself. It was described as an ultimate wartime machine. It was described as backbone of irregular war. It was described as a masterpiece of simplicity. It was described as peak industrial design. It was described as height of military engineering. It was described as focus of British production. It was described as answer to the German threat. It was described as weapon of the future and legacy of the past. It was described as the Sten.